Rust versus Go. It is, without a doubt, one of the biggest debates happening in software right now. You've got passionate fans on both sides, but today we're going to cut through all that noise. In this explainer, we are going to settle this thing once and for all.
Because let's be honest, that's what this is really about, isn't it? This isn't just some academic debate about syntax. We're talking about your time, your skills, your future in an industry that changes in the blink of an eye. So, where are you going to place your bet?
To figure that out, we're not just going to talk theory. We're getting our hands dirty. We are going to build the exact same app, a simple command line weather tool in both languages. We want to see how they feel in the real world, focusing on the journey of building it, not just the finished product.
All right, so part 1, a tale of two CLIs. Let's move past the talk and see what it's actually like to work with these two. Okay, let's zoom right in on the code itself. We're going to look at 3 key moments that really define what it's like to be a developer in each language. How you start a project, how you handle data, and what happens when things, inevitably break.
You can feel the difference in philosophy from the very first command. With Rust, you type cargo new, and poof, you get a whole structured project. It's got Git integration, a manifest file, the whole shebang. It kind of holds your hand. Go, on the other hand, is super minimalist. You run go mod init, and you get one file. That's it. The rest is up to you. It's all about freedom and piecing together simple tools however you want.
All right, next up, a super common task, parsing JSON. In the Rust world, you use this amazing tool called Symbiotic. It's a macro that literally writes the perfect, optimized parsing code for you before the program even runs. So all your safety checks are done at compile time. It's just incredibly powerful. Go takes a simpler path. It uses its standard library, which figures out how to handle the data while your program is actually running. This is called runtime reflection. It's really straightforward, but it means you might not find certain errors until you actually run the code.
Now, this might be the most telling difference between them. In Rust, if a function might fail, it returns something called a result. And the compiler literally will not let you compile your code until you've dealt with that possibility. It forces you to handle it. Over in Go, you have the famous if, err, not nil check. It's a pattern, a convention. It's clear, for sure, but it relies completely on you, the developer, to remember to do it every single time. One is a system of guarantees. The other is a system of discipline. So, you see, these aren't just small technical quirks. Every single one of these choices, right down to how you handle an error, reveals a deep, fundamental philosophy about how software should be built. Let's break down what those two opposing worldviews really look like.
And here it is, all laid out. Rust gives you this integrated tooling, this incredible compile time power, and these guarantees from the type system. It's all about building a powerful, safe system that catches your mistakes before you can even run the code. Go, on the other hand, is all about simple, composable tools, runtime simplicity, and developer convention. It really boils down to this. Rust puts its trust in the compiler to enforce correctness, while Go puts its trust in the developer to write clear, simple code. Okay, we've dug into the code. Now it's time to zoom out and look at the world beyond the text editor. How do these different philosophies actually play out when it comes to jobs, salaries, and where they're used in the real world? This is the ecosystem battle. And let's just cut to the chase. It's the question that's probably on your mind. Which language is going to get you a better paycheck and open more doors right now in 2025? For Go, the market is strong. It's very, very healthy. I mean, it's the language of the cloud. So you're looking at a super solid average salary range, somewhere between $120,000 and $160,000 a year. That reflects a mature, wide open job market for a skill that's consistently in demand. And then there's Rust. The range here is just significantly higher. We're talking starting around $150K and pushing well past $250K. This is what people in the industry call the Rust premium. And it's a classic case of supply and demand. There's huge demand for this critical skill, but a much smaller supply of developers who've mastered it. And this salary gap gets even crazier when you look at high-stakes industries. Take Web3 and blockchain, for example, where a single bug can cost millions. The premium for Rust's safety is massive. The average Go salary is a very, very respectable $160,000. But for Rust developers, it skyrockets to an average of $260,000. That's a $100,000 difference. It just shows you how much value the market places on Rust's guarantees in those critical domains. Okay, so Rust pays more. That means Rust is the winner. Case closed, right? Not so fast. The best language for you depends entirely on who you are and what you're trying to build. So let's break this down into some real actionable advice for 3 different kinds of developers.
Let's find out where you fit. Are you a newcomer just starting your journey? An experienced pro working in the cloud? Or maybe someone who just loves digging into low-level systems?
Okay, if you're new to this whole world, fresh out of a boot camp, or just learning to code, the recommendation is crystal clear. Go Java. Its learning curve is so much gentler. You can be productive in days, not months. And honestly, the job market is just wider and more accessible for entry-level roles. It's the most direct path to landing that all-important first job in tech.
Now, for you senior cloud engineers, the experts out there, the answer is a bit more interesting. It's not either or, it's both. You should use Go for 90% of what you do, building APIs, microservices, all the day-to-day cloud stuff. But for those absolutely critical, foundational pieces like a service proxy or a high-performance database component where speed and safety cannot be compromised, Rust is the weapon of choice. The truly elite engineer of the future uses Go for breadth and Rust for depth.
And finally, if you're a systems programmer, if you come from the world of C or C++ and you love being close to the hardware, the choice is just, it's not even a choice. Learn Rust. It gives you all the low-level control you're used to, but it just wipes out entire categories of bugs before you even compile. It is, without a doubt, the heir apparent for all new systems programming, period.
And all of this brings us to our final verdict. The whole idea of one language winning is just the wrong way to look at it. The future isn't a competition between Rust and Go. It's a partnership. It's symbiosis.
There's this quote that just paints the picture perfectly. Imagine this. The future is a Go application handling all the business logic, and it's making a call through a blazing fast, super safe proxy built in Rust to talk to a rock-solid database that's also built in Rust. You see? Go on top, handling the application logic, Rust underneath, providing the foundational infrastructure.
So at the end of the day, the choice really comes down to a simple question you have to ask yourself. Do you want to build the what? The applications, the services, the features that users interact with every day. That's the world of Go. Or do you want to build the how? The rock-solid, high-performance infrastructure that makes all of that possible in the first place. That is Rust's destiny. The question isn't which language is better, it's which part of that future do you want to build?